Hello, this is Dr. J back with some more Commander X16 game development. It's been a while, as I said in the last couple of videos that it would be. Life has continued to be busy, so progress has been a little slow, and I've started getting back into the swing of things after a long break. But I've now implemented enough that I thought it was worth sharing and putting together another video. First, I'd like to talk about my evolving vision for Dungeon Commander, as I'm still calling it. Again, that may not be its final title, but it's what we'll be using as the working title. So what I'd like to do is whenever I finish Dungeon Commander, which at the current pace is going to be a pretty long time, but that's a different issue. Whenever I do finish it, I would like to ship it with all the different utilities that I am going to use to aid me in building the game, like the map builder and whatever other utilities I end up putting together for it, in order to make the game very easily moddable, so that people can use it to build their own maps and stories and campaigns. And of course, it will also ship with a complete game and campaign that I make myself. But what I'm basically envisioning, if it all works out, is making sort of the Commander X16 equivalent of RPG Maker. RPG Maker being a very long-running series that is pretty much what it sounds like. It is a set of tools to enable people to easily build RPGs that has had many iterations on a variety of different platforms. I basically want to make the equivalent of that for the Commander X16, because I think that would be really cool. So as far as implementation, I decided that the first thing that I would work on is the map system. So I needed to make some decisions about how the maps would be formatted. And what I've decided, and this is not a complete format definition, but it's good enough to get me started, is that we'll have a byte which indicates the width of the map, and then another that indicates the height, and the maximum width and height will be 64 by 64 tiles. And then I'm going to have a variety of tile sets representing different terrain types and the like, and since our memory on the Commander X16 is so limited, we'll have to just load the tile set for the current map, rather than trying to load, every tile set into memory all at once. And so since I'll have different tile set definitions, the next byte in the map format is going to indicate which tile set it uses. And then we're going to have a 64 by 64 set of bytes for the actual map tiles, each of which is just going to be a byte corresponding to which of the tiles in the tile set that is defined for the map is on each cell. Even though maps can be smaller than 64 by 64 tiles, we'll still take up that amount of space in memory, because trying to fiddle around with cramming more stuff into memory when you're working on a smaller map would just be way too complex for the relatively limited benefit that you would get out of doing it. So we'll just always allocate that amount of memory for the map, even when we're on a smaller one. And then we are going to have a mapping. And what I mean by this is there's going to be a discrete number of terrain types. For now, the terrain types that I've defined are clear, wall, water, gap, flyable, and impassable. The idea behind this is that the different types of terrain that the player can traverse might change as the game goes on, or change under different circumstances. For example, maybe you have a world map, and at some point the player acquires an airship, and that allows the player to fly over a bunch of different terrain types that he normally cannot. Or maybe the player gets like hover boots that let him walk over gaps in water, but still don't allow him to walk over walls and, terrain that you need full flight capability to get over it. So that's the idea behind having a variety of terrain types instead of just a strict Boolean. Either you can move over it or you can't. And so what the terrain mapping part of the map format is for is it takes each of the tiles in the current tile set and indicates what is the terrain type that that tile corresponds to. Because, for example, maybe for the sake of visual variety, you'll have half a dozen different grass tiles that look different, but all of them are just effectively a clear terrain type. And so by having this mapping, instead of needing to allocate 64 by 64 tiles twice, once for the map graphics and then again for the terrain on each of the individual cells, we end up saving a huge amount of memory. So that's the purpose of the terrain mapping part. So with the preliminaries out of the way, here is a little map maker that I have built for myself. Although again, my current vision is that I will be shipping these utilities with the game as well, whenever that's ready to go. I built it using JavaScript, which might seem like an odd choice, but I deliberately built it this way so that it will run on virtually any computer with a modern web browser. So extremely portable by essentially building it as a web page. So you can select your tile set here. And by the way, everything here is just temporary testing graphics. None of these graphics are going to be in the final product. They're just crappy graphics I threw together quickly for testing purposes, just to make that clear. And I'm sure that it will ship with a lot more than just 2 tile sets, but this is all just testing data. But for now, there's just 2 tile sets that you can switch between. And then the individual tiles that you can pick are all shown here. So tile set 1 has a whopping 3, and test tile set 2 is going for the world record with a mighty 2 tiles. And then you can set the map size here. 64 by 64 is the maximum, but you can set it to just about any value. You can't make it too small though. The minimum values for the map size are the number of tiles that will fit on a single screen, because the game is not designed to have a map so small that it is smaller than a single screen. So that's the minimum size, and 64 by 64 is the biggest. You can see you get this nice red rectangle showing the bounding area of the map size that you've set. If you want to fill the entire map with a single tile, you just turn bucket fill on, and there you go. You can just fill it with whatever, then turn it off. You can toggle the grid on and off. Grid obviously useful for when you need to pick a very specific cell without any ambiguity, but it can be a little visually distracting, so that's why you can also turn it off. There's also undo and redo with 30 levels worth of undo and redo. That was basically chosen arbitrarily. In theory, you could make it much more than that because each level of undo doesn't actually take up all that much memory. And then you just pick the tile that you want and click on the place on the map where you want to place that tile. So, you know, it's a map editor. I'm sure we're all familiar with these. There's nothing really mind-boggling about it. They're so small that it's a little hard for me to click with precision on the tiles that I want. So that's an issue that I might have to try to come up with some kind of solution for. I guess one solution is you can just zoom way the heck in. Let me see if that breaks the math that determines which tile you're over. No, it doesn't. I actually hadn't even tested that. I seem to be making a face. That was not intentional. But anyway, so you can see that that's all working, just to show that the undo and redo works. There you go. We hit our undo limit, so I'll just spam redo, and we get back everything that we were putting down. So that's nice. And loading and saving is also working. So I go to load map. You can't see the load map dialog, but it has just appeared, and I will navigate to the right folder. Okay, and then load up another test map that I made. Okay, and so you can see that loading and saving maps is also working. So that's the map editor. And I built that before I even started doing any Commander X16 code because I just wanted to have a utility that I could use to start building maps for testing. As you can see, that's all working pretty nicely. It was pretty easy to put together too. It was only like one afternoon of work to get this thing working, so that was nice. Now let's have a look at some Commander X16 code. The first thing I'd like to draw your attention to is this logging file that I've made. It occurred to me very quickly that now that I'm going to be making a real game, I'm going to need some kind of debugging facilities in place. Now, I'm kind of old school, and I rely very heavily on print line debugging, where you just print out values that you're interested in whenever you're debugging something. And that is not the most trivial thing in the world to do on the Commander X16. But I realized that I was going to want some kind of functionality for that. Otherwise, debugging problems that came up was going to be exceedingly difficult. So the way that I decided to do this is I have, oh, this is the wrong thing. I wanted to go this way. Sorry about that. Okay, so what I do is I just have a log array, just an array of characters. And this has to be of a fairly limited size because this is going to live in memory. And remember, we only have 40 kilobytes of usable low RAM at our disposal. And you can eat that up with even just plain text really quick. So I've defined my log size as 1 kilobyte. And even this is all going to get turned off when I'm done working on the game and I don't need to debug anymore. I will undefine debug, and then free up all of this once it's no longer needed. But for right now, 1 kilobyte of my 40K of low RAM is taken up with my log for debugging purposes. And I added a few methods. One is just adding a message to the log. Another is when you want to add a number to the log. And so that does the logic necessary to convert a numeric value into ASCII characters for the purposes of writing out to a debug file. For convenience, I created a method, or excuse me, a function. Technically, I believe a method has to belong to a class, and of course we don't have any of those in C. So a function, add log new line, and what that does is it just adds a new line to the log. And okay, sorry, I was thinking of this one. This is the convenience function that I was referring to, which actually calls log message, number, and new line all on your behalf. It's called add log entry, and what it does is you give it a message that you want it to print out. If the message is not null terminated, you have to tell it how long it is. Otherwise, it's not going to know when to stop writing the message to the log array. You can just put this to 0 if the message is null terminated, and it'll do the right thing. And then you give it any number that you want to print out. I guess I do have this defined as unsigned long, and maybe I should change this to signed long so that it can also print negative numbers. So that's a modification I'll think about making offline. And what it does is it prints the message first, then appends to that whatever is the number that you want printed out, and then puts a new line after that. And the purpose of this is, the most common reason that you're going to be logging stuff is because you want to check the values of certain variables as your program runs. So you feed it a message that allows you to pick that particular log line out of your debug log, and then whatever the number is the variable is that you want to have its value logged, and then stick a new line after that for readability. So add log entry is something that I found myself calling all the time while I was building and debugging my initial functionality. And then finally, after you have printed out, after you have logged whatever messages and variables it is that you want to add to your debug log, you then call write log, and this will write all of the output from the log array into a text file called debug.log, which will then contain all of your debug messages. And I have already found this pretty helpful for debugging a couple of errors and bugs that came up while I was implementing this initial functionality. In fact, I would venture to say that this is so useful that many Commander X16 developers would probably benefit from having this functionality. So I am very likely to take this and put it into the X16 library so that it's functionality that's just available to everybody and isn't just living here in the proprietary code for my game. So that's why I went into so much detail on this, because like I said, it is likely to end up in the X16 library so that it's available for everybody's use. Okay, so having explained that, next we have the logic for actually loading the game maps that we made with our JavaScript utility in for use on the Commander X16. And this is done in stages. The first thing that we do is we load in a map with the file name supplied to the function into our game map struct right here. And just to review, that has, at present, it's going to have more stuff in the future, but right now it has the width, the height, the number of the tile set you're using, because the tile set definition is actually in a separate file. the actual map tiles, so that's the 64 by 64 array, although it's flattened into a one-dimensional array once it gets loaded into the Commander X16. And then the terrain mapping, which is actually also specified in a separate file and gets populated into this part of the game map struct after the initial map file is loaded. So this is where we first load the map file and populate it into our game map struct. We then set the exist tile map width and height based on the width and height defined in the map file multiplied by the dimensions of our tiles. And I mean, I figured this was pretty obvious, but yes, I am using the exist team library that I built to make this. So I have access to all that functionality that I spent the previous 10 or so videos building. Now, multiplication on the Commander X16 is slow, as I think we've discussed in the past, because there is no hardware multiplication on the 6502 CPU, so it has to add in a loop if you're multiplying by anything other than a power of 2. Now, as it turns out, our layer 0 tile dimensions are a power of 2 because they're 64, and maybe the CC65 compiler is smart enough, since this is a hard-coded power of 2 value, to convert this multiplication into bit shifting. I would hope so, because that's a very basic optimization for a compiler to do. But I haven't checked that. I don't know for a fact that it will be smart enough to do that. And honestly, it doesn't matter, because this is not code that is running as part of our core game loop. This is code that will run every once in a blue moon when we load a new game map. So it doesn't really matter that this is slow. You don't really have to worry too much about optimizing code that is hardly ever going to be running during the lifetime of your program. It's the code that's running constantly in your core game loop that you need to go out of your way to make as optimally performant as possible. But anyway, once we have defined the width and height of our map, next we get the tile set and we have to load the tile graphics into the tile-based part of our VRAM. And so the graphics list is in a separate file, and that's just going to be a series of indices into our metadata, our graphics metadata, so that it knows what are the tile graphics defined in our exist team metadata file that it's going to need to load and then copy into VRAM. And so that's what this next chunk of code is for. All right, so then once we get past that part, next thing that we need to do is load the terrain mapping for the tile set, which, as I previously discussed, maps each of the actual tile graphics that are used in that tile set for that map to the terrain types, which are defined up here. So that instead of having to have a 64 by 64 array of terrain values, we just load this mapping, which is going to be much, much smaller. So it's a nice big memory savings for us. And so that is specified in another separate file, which is called TM, followed by the numerical value of the tile set. And so then we load all of that. And then finally, we load the tile indices into the map base part of our VRAM. And once we get that done, our map is fully loaded and ready to use in the Commander X16's memory. The next thing that I wanted to get working before I made a video and started showing stuff for my channel was actually having a player sprite to put on the map and walk around. So the next thing that I did was put together a sample sprite. Well, I say put together, but in fact, this is a sprite ripped from a Nintendo Entertainment System game with some slight modifications. And if you happen to recognize this sprite, then you get a heaping helping of retro game nerd points. It is from a game that back in the day was really excellent. To this day, still hasn't gotten a proper remake. But that's a completely different subject for a different video. But in any case, as you can see, I assembled this sprite, which has our character walking in a north, east, and a south direction. And there's no west direction because you may recall that the Commander X16 has the capability built into it to vertically and horizontally flip sprite objects, so we can save a reasonable chunk of our VRAM memory by instead of having a separate sprite for walking west, just take the walking east sprite and then turn on the horizontal flip bit when the player is walking in that direction instead of to the east. Once I had my sprite assembled, converted into the exists image format, and then wrote the code to load it into the program, the next step was to actually make it controllable so that the player can wander around the map and be properly animated. And this was a little bit more complicated than you might think. One of the reasons it's more complicated is because you can't just shift the map whenever the player is walking around the screen. And the reason for that is because the maps in Dungeon Commander do not loop or repeat. So you can't just keep scrolling the map as the player gets close to the edge of the screen, or the player is going to be able to see the opposite side of the map, which we don't want. So what you actually have to do is, once the player is near the edge of the screen, you stop scrolling the map and instead you move the player sprite. And that's something that you have to keep track of separately on both the X and Y axes. You also have to make sure that you load the proper sprite based on the direction the player is facing, and then move the other sprites for the other directions off screen or otherwise disable them. Animate the sprite while it's walking from one tile to the next. Make sure to flip the sprite when the player is walking west instead of east. And of course, as the player moves around the map, you have to check the tile that the player is attempting to move into to make sure it's a tile that the player can legally move into, which currently I have defined as only tiles with a terrain type of clear. And because I'm tracking the player's coordinates as X and Y coordinates, there's also the necessity of converting between the two-dimensional X and Y coordinates and the one-dimensional flat array that the terrain actually exists as in memory. But of course, that's not something that's terribly difficult to do or anything. It's just yet another consideration. And when you add all of that together, it ends up being a surprisingly non-trivial amount of code to get walking around the map working properly. All right, with that fairly abbreviated explanation out of the way, here it is in all its glory. So as you can see, my nice animated sprite is able to walk around the map. And let me show that thing I was talking about where once you're near the map edge, you have to stop scrolling the screen and actually start moving the sprite around the map instead. And like I said, you have to track that separately on both the X and Y axes because you might have to move the sprite off center either to the left or right or up or down while also still being able to scroll the map on the other axis. So, I mean, it's not super complicated or anything, but there is a little bit of a non-trivial amount of logic involved in getting that working. And the debug log that I put together was fairly helpful with fixing a couple of little mistakes that I had made. And although you can't see it, I am pressing the button when trying to move on to non-grass terrain, and it's not letting me do so. So checking the terrain types is working properly. So yeah, not too bad. If I were coding this game using my usual tools, this would have been a couple afternoons of work. It was a bit more than that, doing it on the Commander X16, but I'm still having a lot of fun doing this programming on actual retro hardware. So the fact that it is more challenging is not a bad thing to me at all. I'm really enjoying it. So now that this most basic of functionality and the basic aspects of the map builder are done, what's next? Well, I want to continue getting the map system working before I start working on things like game menus or the battle system or any of that. So the next thing that I'm going to do is start implementing a simple scripting system that allows me to trigger events by walking onto certain tiles or going up to something and then, like hitting the A button or something like that. And being able to make changes to the map in response to doing that, like, for example, making a bridge appear. And also being able to do stuff like launch little cutscenes. And so having a simplistic cutscene system working is also going to be something that is on the near future to-do list. So getting those map events, scripting system, and maybe a little bit of cutscene system working are the things I'm planning on working on next. Now, Like I said, life is continuing to be fairly busy, so progress is continuing to not be blazing fast. So I would expect for the foreseeable future that the devlog videos will continue to be spaced out apart a little bit, not coming fast and furious. But rest assured that I am going to be continuing to work on this, and that I will to keep all of you fine folks updated whenever I make enough progress that I feel like it's worth demonstrating. So that pretty much concludes this demonstration for now. Like I said, I am planning on adding that debug logging functionality to the existing library sometime in the near future. So if anybody's actually using that, you can look forward to that little improvement. In the meantime, aside from all the other life things I'm doing, I will be continuing to work on Dungeon Commander as time permits, and post more videos whenever it's worthwhile to do so. So that's going to do it for now, and I will see you all in the next video. Catch you later.